Okay, so today I decided that I should be covering my backlog or the things which I have not yet considered to be studied. So one of these chapters is called Circles, and it in depth is actually a very easy chapter, I guess, because the formulas do not look that hard and the concepts are also kind of what we are taught in school, so I think it should be okay. So I will be dealing with all of the in chapter exercises and the exercises given for practice. I don't know how long it's gonna take me, but yeah, that's it. So enjoy watching me doing calculations and stuff. So I don't even know how many of them am I going to get correct, and thankfully we are given answers over here. So these are answers which I have hidden because obviously why not. So yeah, I will be solving these things and then I will be checking if what I solved is correct or not. So let's just get to work. So this is in chapter exercise 1, and here's the first question. Equation of a circle with center at the origin and which passes through the point alpha comma beta is. So center is at the origin and it passes through the point alpha comma beta. So the radius squared, that's going to be equal to alpha squared plus beta squared, and that should be equal to x squared plus y squared, Pythagoras theorem. That's easy. What's the next question? I'll just change it to stroke eraser maybe. So stroke eraser. Cool. Okay, the next question is the equation of the circle with center 2 comma minus 3 and radius 5 is. So it's gonna be x minus 2 squared plus y plus 3 squared equal to the radius squared, which is 25. So let's just simplify this. X squared minus 4x plus 4 plus y squared plus 6x plus 9 equal to 25. So x squared minus 4x plus y squared plus 6x. 4 plus 9 is 13. 13 minus 25, so 25 minus 13 is 12. So it's minus 12 equal to 0. That's also easy. I guess I should be checking the answers first. Yeah, so let's just write that down actually. So x squared minus 4x plus y squared plus 6x minus 12 equal to 0. So that's my answer. The next question is 0 comma 2 and 2 comma 3 are endpoints of a diameter of a circle, then its equation is. So this is based on the diametrical form of the circle. So it is given like that. So like x minus 0 into x minus 2 plus y minus 2 into y minus 3 equals to 0. So like this will be a quadratic in x and y, which will have no xy term, and the coefficient of x squared and y squared is 1. So it really is a circle and it is passing through 0 comma 2 and 2 comma 3, right? Because yeah, that is satisfying the equation. So that should be the correct answers. Like this is gonna give me x squared minus 2x plus y squared minus 5y plus 6 equal to 0. So yeah, actually let's just write it down over here. So x squared plus y squared minus 2x minus 5y, right, equal to minus 6, like plus 6 equal to 0. Okay, what's the next question? So equation of a circle which passes through 3 points 0 comma 0, a comma 0 and 0 comma b. Oh, this is actually an easy one. So this is what it's gonna look like. So this is 0 comma 0, this is this is 0 comma b, and this thing is a comma 0, right? So the key point over here is this 90 degree. So this is going to be the diameter. So now we can just use the diametrical form of the circle. So like x minus 0, yes, into x minus a plus y minus 0 into y minus b equals to 0. That should be doing it. So this is x squared minus ax. Actually, let's just write over here x squared minus ax plus y squared minus by equal to 0. Yeah, that looks cool. The next question is find the equation of a circle with center 3 comma 4 and it is touching the x-axis. Okay, so this is the x-axis. The center is 3 comma 4, somewhere over there. Okay, and it's touching the x-axis. So it might or might not touch the y-axis, or like not pass through it or intersect it, I don't know. but it's gonna touch the x-axis. So how do we do it? Well, first of all, let's find the radius. Because it is touching, this is the right angle, right? So this is like the perpendicular distance stuff. So this is 3, I guess, and this is 4. So the radius is 4. So like radius squared is 16, and that should be equal to the shifted x and y squares, squared summed. Okay, so x, what's this point? This is 3 comma 2, right? No, 3 comma 4 actually. Okay, so x minus 3 squared plus y minus 4 squared. Yeah, that should be it. So let's just deal with this. R squared is 16, so this is equal to 16. So x squared minus 6x plus 9 plus y squared minus 8x plus 16 equals to 16. This cancels. So you just write this down. X squared minus 6x plus y squared minus, wait, this is y, minus 8y plus 9 equals to 0. Let's move on. Equation of the circles with radius 5 and touching the y-axis at a distance minus 4 from the origin. Oh, distance minus 4. Well, that's weird, but we just deal with this. So I guess this is like sine length. Okay, so it is touching y-axis at distance minus 4 from the origin. Oh, that's weird. Oh, okay, so wherever it is touching, that point has its y coordinate as minus 4. Okay, so this is like 0 comma minus 4. And anything else? So radius 5, so this distance is gonna be 5. So this is actually 5 comma minus 4. So 5 comma minus 4 is the center of the circle. So now it's pretty easy. So like x minus 5 squared plus y plus 4 squared equal to 25. So x squared minus 10x, 25 gets cancelled, y squared plus 8x plus 16 equal to 0. So just write it down. X squared minus 10x plus y squared plus 8x plus 16 equal to 0. Next question. Equation of the circles touching x equals to 0, y equals to 0 and x equal to 2 is. So x equal to 0, y equal to 0 and x equal to 2. So that's over here, and it's got to be touching these things. So this is the line which it is touching, this is the line which is touching, and this is the, okay, so there are actually multiple circles, I guess 2 circles. Okay, so the first circle is going to be this one, and next we're going to be having this circle. So yeah, what's the diameter first of all? So diameter is 2, so radius is 1. So this point is 1 centimeter above this axis. So and this is also 1, this is also 1, so this has to be 1 comma 1, and this has to be 1 comma minus 1. Yeah, that should be doing it. Is there any other way that I can draw a circle? No, I don't think so. Okay, so that's gonna be x minus 1 squared plus y plus minus 1 squared, right? That's gonna cover both circles at the same time. So 1 arrow 2 birds, something like that. Okay, and radius is 1, so 1 squared is 1. So x squared minus 2x, 1 gets cancelled, plus y squared plus or minus 2y, 1, sorry, plus 1. What am I writing? That should be doing it, right? Yeah. Where is it? Yeah, x equal to 2 is. So this is x squared minus 2x plus y squared plus or minus 2y plus 1 equals to 0. Next question. The equation of circle with origin as center passing through the vertices of an equilateral triangle whose median is of length 3a is. So let's deal with the geometry first, and then we will talk about the coordinates. So it is circumscribing an equilateral triangle with median 3a. Oh, that's really weird. So this thing is 3a, right? Okay, so we just draw this out. Hey, we know this angle has to be 60 degrees, and guess what? Actually 60 cosines, like this is r, right? This is r, this is r, this is r. So this length, this has to be r upon 2, because r into cosine 60 degrees, that's r upon 2. So r plus r upon 2, that's 3r upon 2. That has to be equal to 3, right? Because it's, yeah, it's gonna have median of length 3, 3a actually. Okay, so that's gonna give me r equal to 2a. Oh, that's nice. And now let's come to the coordinates. So origin is the center of this circle. So we just have x squared plus y squared equal to r squared. So this is 4a squared. Yeah, that should be correct, unless I'm making some silly mistake. At least I knew the method. Next question. Equations. Okay, so there are multiple equations now of a circle touching lines x equal to, oh, it's like the previous question. So let's just draw this out. So this is the coordinate axis. X equal to -1 is over here. Okay, x equal to 3 somewhere over there. Y equal to 3, this is over there. Yes, so just like the previous question, there are going to be multiple circles. So this is one of the circles, and here's another circle. First job, determining the radius. Okay, what's the radius? Hey, first of all, actually let's just determine what this point is gonna be. So yeah, so this is actually y equal to 3. Yeah, and this is x equal to 3. This is x equal to -1. So this coordinate is -1 comma 3, and this coordinate is 3 comma 3, which means that this midpoint, this has to be 3 minus 1 is 2, so 2 upon 1, that's 1 comma 3. Cool. What's the radius now? So the distance between -1 and 3, that's actually 4 units. So this is 4, so radius has to be equal to 2. Cool. So this center is gonna lie directly below it, so this is gonna be 1, and then you subtract 2 from the y, so that's gonna be 1, and over here you add 2, so 1 comma 5. You got the centers, you also got the radius, basically got the equation. So let's deal with the first equation. X minus 1 squared plus y minus 5 squared, right? Did I do it correct? Well, I guess yes, because 1 comma 3, yeah, that's correct, and radius is definitely 2, so y, yeah, yes, this looks correct. Let's move on. So x minus 1 squared plus y minus 5 squared, right? Yes, equal to r squared. So r is 2, so it's supposed to be 4. So x squared minus 2x plus 1 plus y squared minus 10x plus 25 equal to 4. So x squared plus y squared minus 2x minus, oh, this is y. Why do I keep writing x in place of y? Minus 10y. Anything else? So 26 minus 4 is 22 equals to 0. The first equation. Cool. Go for the second one. So it's going to be x minus 1 squared once again. So this is x squared minus 2x plus 1. Okay, and then you're going to have y minus 1 squared. So y squared minus 2y plus 1 equal to r squared. R squared is 4, right? So x squared plus y squared minus 2x minus 2y. Wait, it's minus 2, right? So it is 1 plus 1 is 2, minus 4 is minus 2 equals to 0. That's another equation. Just write them down. Okay, what was the question here? The question was like x squared plus y squared minus 2x minus 10y plus 22 equals to 0, and this is x squared plus y squared minus 2x minus 2y minus 2 equals to 0. Next question. Parametric coordinates of any point on the circle x squared plus y squared minus 4x plus 6y minus 12 equals to 0 r. This is gonna be easy, because just find the center first of all. The center is 2 comma minus 3. Yeah, just take half of these things, right? I think they call them 2g and 2f. I don't know, I don't really deal with that general equation anymore, because that looks stupid to me now. I mean, not in a harsh way, but whatever. What's the radius? So radius is 12, right? So plus 12 plus, so 2 squared is 4 plus 3 squared is 9, right? So 4 plus 9 is 13. This is going to be 25. This is radius squared, so that's going to give me radius equals to 5. Cool. So now just gonna shift this like 2 plus r cosine alpha, so 5 cosine, this is, let's just use theta, so yeah, minus 3 plus 5 sine theta. It's cool, doable. So yeah, parametric coordinates, so this is gonna be 2 plus 5 cosine theta and minus 3 plus 5 sine theta. Done. Let's go to the next question. Find the circle of the triangle found by the lines x equals to 0, x plus y equal to 3, and x minus y plus 1 equal to 0. Once again they gave us a right angle, because x plus y plus 3 and x minus y plus 1, they have slopes that multiply to -1, so there's a right angle over there. Let's just find where do these lines intersect x equal to 0. So x equal to 0 and this thing, that's gonna give me y equal to -3. So one intersection point is 0 comma minus 3, and x equals to 0 and this line, that's gonna give me y equal to 1. So 0 comma 1 is another intersection point. So this thing joining these 2 points, that will be the diameter of this circle, right? So now it's easy, it's just x minus 0 into x minus 0 once again, plus y minus 3 is plus 3, y plus y minus 1 equals to 0. So x squared plus y squared, 3 minus 1 is 2, so plus 2y minus 3 equals to 0. Right, we'll just write this down. Where should I write this down? Just note this first of all. Okay, right, x squared plus y squared plus 2y minus 3 equal to 0. Man, my handwriting is really bad. Next question. Find the equation of the circle of the quadrilateral found by the lines x equal to plus minus 1, y equal to plus minus 2. Okay, so first of all, just draw the quadrilateral. So x equal to plus minus 1, this is x equal to 1, this is x equal to minus 1. Oops, sorry, this is y equal to 2, this is y equal to minus 2. Sorry, I drew the different line, whatever. This is x equal to 1 and this is x equal to minus 1. So these coordinates, the good thing is that this is a rectangle, so once again you got a 90 degrees. So yeah, this is going to be 1 comma 2, yes, and this is going to be minus 1 comma minus 2. So yeah, the center is over here. Why are we even dealing with the center? Let's just find the equation of the circle. So this is gonna be x minus 1 into x plus 1 plus y minus 2 into y plus 2 equal to 0. So x squared plus y squared equal to, well, 1 plus 4, right? So that's going to be 5. X squared plus y squared equal to 5. Cool, let's move on. If the line x minus y plus 1 equal to 0 is a chord of the circle x squared plus y squared minus 2x plus 4y minus 4 equal to 0, then find, okay, so question got cut off. Find the length of this chord. Alright, so let's deal with coordinate geometry first to find some distances, and then we will deal with geometry. So what's the center of this circle? It's 1 comma minus 2, I think, and you got this line x minus y plus 1 equals to 0. So this perpendicular distance, that's going to be equal to 1. Minus of minus 2 is plus 2 plus 1. The magnitude of that is the same thing. So upon square root of 1 squared plus 1 squared is 2. Cool. So this thing is 4, right? So 4 upon square root 2 is 2 square root 2. So this distance is 2 square root 2. Alright. So now we know what's the distance between the center and the chord. Okay, cool. This thing is 2 square root 2. What is the radius of this circle? So it's going to be 4 plus 1 squared is 1 plus 2 squared is 4. So that's 9. Right? This is r squared. So it's going to give me r equals to 3. So this distance is 3. So using Pythagoras theorem, this is just 1. So this is also 1. So the length of the chord is 2. Yeah, that was easy. Let's go to the next question. First erase this. Okay, I guess this is also the last question of this in chapter exercise. The lines 2x minus 3y equals to 5 and 3x minus 4y equal to 7 are the diameters of a circle of area 154 square units. The equation of the circle is, oh, so these are the diameters, right? That's nice. So that's gonna mean, that means their intersection point is the center. Just find the intersection point, multiply by 3 maybe, so 6x minus 9y equal to 15, and 6x minus 8y equal to 14, subtract y equal to minus 1, that's gonna give me 2x equals to 8, so x equal to 4. So 4 comma minus 1, that's the center of this circle. And area, come on man, what do they think? How did they give us this question? Okay, 154 is area, so it's now whatever, just take pi into, I feel like I'm in school. Yeah, pi into r squared, so r squared equal to 154 upon pi, so r equal to square root of 154 upon pi. Well, actually, why are we even doing that? You got the center, you got r squared, so x minus 4 squared plus y plus 1 squared equal to 154 upon pi. So that's going to give me x squared minus 8x plus 16 plus y squared plus 2x plus 1 equal to 154 upon pi. Do they want us to approximate pi as 22 by 7? Maybe, because 15 looks like, yeah, it's a multiple of 14. So let's just approximate it as 22 by 7. So, oh, it's okay, fine. At least it's also a multiple of 11. So that's nice. This is gonna be 2, this is gonna be 14, so this is gonna be 7, r squared is 49. So this thing turns out to be 49. I really feel like a school kid right now. I was not expecting this kind of problem. This is y plus 2y plus 17 equal to 49. Did I do it correct? Yes, I did it correct. So that's minus 16, this is 17, right? So minus 32 equals to 0. Write that down. X squared plus y squared minus 8x plus 2y minus 32 equals to 0. Let's see what are the answers. Okay, first of all, just erase all this stuff and cut this. Cool. So the first answer was x squared plus y squared equal to alpha squared plus beta squared. Too easy, nothing challenging. Next you got x squared plus y squared minus 4x plus 6y minus 12 equal to 0. Yeah, that looks correct. Next question, you got x squared plus y squared minus 2x minus 5y plus 6 equal to 0. Yes, correct. So 1 2 3 correct. 4x squared plus y squared minus ax minus by equals to 0. Yeah, correct. X squared plus y squared minus 6x minus 8y plus 9. Yeah, that is also correct. X squared plus y squared plus minus 10. Wait, for what question is that? Plus minus 10. This is for the 6th question, right? Equation for circles. There is 5. Touching y-axis at distance minus 4 from the origin. Why did I not put plus or minus over there? I mean, I clearly did do it for 2 circles. Then why did I not put it in the equation? I don't know. But I guess that's correct because, yeah, it should have been some minor mistake because of which I got the answer. 7th. Alright, so yeah, I did put plus minus over here at least. Since minus 4 from the origin. Okay, wait, maybe I did not do those 2 things. Well, whatever, at least I got it now. Okay, 7th question is also correct. I mean, this is ambiguous, that I don't know if I did it or not. 8th question, the equation of a circle with origin as center passing through the vertices of an equator. Why am I reading the question? X squared plus y squared equal to 4 squared. Yes, correct. Next, x squared plus y squared minus 2x minus 10y plus 22 equals to 0, and x squared plus y squared minus 2x minus 2y. Yes, it's correct. 10th, yep, correct. 11th, yes. 12th, x squared plus y squared equals to 5. Yes. 13th, 2, correct. 14th, wait, 14th is not correct. It's not correct. Why? Let's just do it once again. So these lines are the diameters of a circle of area 154 square units. The equation of the circle is, okay, so what did we do? Just solve for these two equations, like 2x minus 3y equal to 5. So multiply by 3. 6x minus 9y equal to 15. Multiply this thing by 2. So no, by 2. So 6x minus 8y equal to 14. That should be correct. So y equal to minus 1, just subtracting. So put that over there. So we're gonna get 2x. There's where I went wrong. So 2x minus 3 into minus 1 is plus 3 equal to 5. So 2x equal to 2. It happens a lot of times. So x equal to 1. Okay, so this thing is 1 comma minus 1. That's the center, right? This is the center of the circle. Area is 154. So we are still gonna get r equal to 7, right? Because that must be correct. I cannot make two mistakes in the same question. That would be very bad. So x squared minus 2x plus 1 plus y squared plus 2x plus 1 equal to 49. So x squared minus 2x plus y squared, this is y, plus 2y minus 47 equals to 0. Is that correct? Yes, that's correct. So now I did it. Cool. Let's go to the next exercise. And yes, this is all from the PACE booklet, PACE IIT and Medical. Okay, in chapter exercise 2, let's deal with the first part first. The equation of the tangent to the circle x squared plus y squared equals to 16 at the point 2 comma 2 square root 3 is. So tangent to the circle x squared, actually just magnify this. Okay, tangent to the circle x squared plus y squared equal to 16 at the point 2 comma 2 squared. This is actually very doable. Just take a derivative. So 2x plus 2y into dy by dx is m equal to 16, right? And put these coordinates in there. So actually 16, right? Over here is 0. Cool. So put 2 over there. So we're gonna get 4 plus 4 root 3m equals to 0. So m equals to negative 1 upon root 3. Not bad. So tangent to this circle at that point is, I guess there's another method too, but let's just deal with this. So where was I? Yes, y minus 2 square root 3 upon x minus 2 equal to negative 1 upon square root 3. So y square root 3 minus 6 equal to negative x plus 2, right? So x plus y square root 3 minus 8 equal to 0. We'll just write that down. X plus y square root 3 minus 8 equal to 0. Cool. And the other method, I guess I learned it online, I don't know, but it's kind of a trick for any equation of the quadratic form, right? The general quadratic form. We just write that down once again. Ax, I don't think there was ax squared, or I don't know, ax squared plus by squared plus cxy. I don't know, I'm just making variables up, plus something like h x plus gy plus f equal to 0. So for that equation, the tangent to that curve at the point x1 comma y1, that's given by ax1x plus by1y plus c. So I don't really know about this term, what do we do for that term? So I'm just gonna ignore that for some while. Plus I told you I'm not very good at this chapter because I am currently in backlog. And h into x plus x 1 upon 2 plus g into y plus y 1 upon 2 plus f equal to 0, right? So that's what we do to find the tangent at that given point. And I guess it also works a lot of the time, yeah, at least for circles and parabolas. And I'm myself did for eclipses too. So for eclipses too it kind of works, yeah. So for those three curves it at least works. I'm gonna use that maybe. So this is gonna be 2x plus 2 square root 3y equal to 16. Hey, yeah, that's the same equation and much easier too. Okay, next question. Write the equation of the tangent to the circle x minus 1 squared plus y plus 2 squared equal to 10 at the point 2 comma 1. Okay, at the point 2 comma 1. Yeah, that shouldn't be that bad. Maybe I can also do it using slopes, right? So because we are given the point at, so it's at 2 comma 1 and clearly 2 comma 1 must be satisfying it, right? Yes, it is satisfying it. So just deal with it like this. So the center is 1 comma minus 2, the point is 2 comma 1, and you have to do this thing. Then here's your tangent. This is called the slope m, right? So what is this slope? This slope is 3 upon 1. So this slope has to be negative 1 upon 3. So y minus 1 upon x minus 2 equal to negative 1 upon 3. So 3y minus 3 equal to negative x plus 2. So 3y plus x minus 5 equals to 0. Yeah, easier. 3y plus x minus 5 equals to 0. Much easier than opening up the brackets and then using the trick. Next question. Find the equation of the normal to the circle x squared plus y squared minus 3x minus 6y minus 10 equal to 0 at point minus 3 comma 4. I guess here it will be much more beneficial. So minus 3x plus 4y minus 3 into x plus x1 is minus 3 upon 2 minus 6 into y plus 4 upon 2, right? Minus 10 equal to 0. Now what? Let's multiply by 2. So minus 6x plus 8y, right? Plus 8y. Minus 3x plus 9 multiply by 2, so it's minus 6y plus, no wait, minus 24. Minus 20 equals to 0. So anything cancels? Nothing. So minus 9x plus 2y. 9 minus 44 is minus, what is that, 35? Yeah, equal to 0. So yeah, that should be the equation, or I can write it as 9x minus 2y plus 35 equal to 0. I don't know, this looks like it could be wrong. Let us deal with this. Next question. The angle between the tangents from alpha comma beta to the circle x squared plus y squared equal to a squared, where s1 equal to alpha squared plus beta squared minus a squared is. So tangents from alpha comma beta to this circle and the angle between those tangents, okay, x squared plus y squared equal to a squared, where s1 is alpha squared plus beta squared minus a squared is. I think there was some method for finding these tangents. Yeah, I guess there was some method, but I don't know that method. So yeah, let's just deal with this. So this is the circle, I guess. Yeah. Oops. This is the circle centered at 0 comma 0. Okay, radius a. You got some random point alpha comma beta like that. What's what's the distance, maybe I should ask. I don't know. Oh yes, I remember. This is actually the power of the point P. Let's call this. So this is the power of the point P with respect to this circle, and it is actually equal to the square of the tangent. But how is that helpful? I don't know. I don't know how that is helpful in any ways. Right. I still remember something from poles and polars. Yeah, but let's not use that. Let's not get messed up with that thing. Okay, so let's say that it is tangent over here. Cool. So let's say this point is h comma k. So we are gonna have beta minus k. Actually, not even h comma. Let's actually choose a cosine theta and so a cosine theta and a sine theta for that. I mean, that's much better, right? So beta minus, what is this, beta minus a sine theta upon alpha minus a cosine. Actually, now that we know how to parameterize for any circle, I guess this is a much better method. This has to be equal to, actually this multiplied by that slope, the other slope, which is this, right? This is a tan theta, right? So it's just s upon c. This is equal to -1. So yeah, it's gonna be like beta times s minus a times s squared equal to negative alpha times c positive a times c squared. So beta s plus alpha c equal to a into s squared plus c squared, just a. So yeah, that's much better. Actually, this is like a general equation. So for any random point alpha comma beta, we can use this equation when we are having a circle centered at 0 comma 0. Cool. So yeah, it's kind of nice. Okay, and wait, but we are not asked that. We are actually required to find the angle. Oh, that's not nice. So we found out the equation. We were not supposed to do that. We are supposed to find the angle. Yeah, can we just use geometry maybe, or do we have to use this s1 as some kind of parameter maybe? I don't know. So what if I use that as a parameter? So alpha squared plus beta squared equal to s1 plus a squared. So this length squared is s1, and that's not helping much. Oh, that's it. Sorry. So this is the equation, and it's good that I found it out, but it's not really required. So yeah, we can just use geometry and get it done. So what's this length? This length is just s plus a squared, square rooted, right? And this distance is just a. So let's call this angle theta, and this is 90 degrees because tangent. So sine theta equals to a upon square root of s plus a squared. Yeah, that's nice. So yeah, so 2 theta, that's the angle between the tangents. That's going to be equal to 2 sine inverse of a upon square root of s1 plus a squared. So really it has to do nothing with alpha or beta. Yeah, nice. Cool, let's get moving. If the lines 3x minus 4y plus 4 equal to 0 and 6x minus 8y minus 7 equal to 0 are tangents to a circle, then the radius of the circle is, oh, what's the radius of the circle? These lines are tangent to that circle. That's kind of weird. How am I supposed to solve this? What do I do? This does not make sense. Wait a second. So you're given 2 random lines and you are told that find the radius of the circle which has these two as tangents. I don't think this is doable, because guess what, you can form this smaller circle over here, right? So over here these 2 lines are still tangents, but then we can also form this bigger circle, right? Yeah, well, why is that? Because of symmetry. Wait, not symmetry, I think it's called similar triangles. Yes, similar triangles. Okay, So that means this radius is not determinable. I guess maybe they want us to parameterize this, but then with what? This does not make any sense. Okay, yeah, I'm just gonna say it's not determinable because just given, oh, it could be a thing that maybe these two lines are, yes, as I expected, these two lines are actually parallel, so that means maybe we can actually find out the radius of that circle. Okay, so that's like a special case because then there's going to be exactly one what do we call it, one radius that's going to exist. I don't know. Okay, let's multiply this by 2. So 6x minus 8y plus 8 equal to 0, and 6x minus 8y minus 7 equal to 0. So the way to find the perpendicular distance between these lines is 8 minus of minus 7, that's 15, upon the square root of 6 squared plus 8 squared, which is like 15 upon 2 square root of 3 square plus 4 square, that's 5. Okay, and this turns out to be 3. So that's it. 3 by 2 is actually this is actually 2r, so radius is 3 by 4. Nice. Radius of the circle is 3 by 4. That's nice. Let's get going to the next question. Okay, the next question is equation of the director circle of the circle 2x squared plus what. I think I remember what a director circle is. So if you got a circle like this, a director circle is like just another circle, just another concentric circle, but it has such kind of radius that from any point on this director circle, if I draw these tangents, these are going to be perpendicular to each other. In other words, these are going to be of the length r, right? So this is r, so this length is just square root 2r, right? So that's pretty easy. Yeah, so the equation of the director circle of the circle 2 into x squared plus y squared equal to 1 is, so this is just x squared plus y squared equal to 1 by 2, which is r squared, right? So for this circle you have capital R equal to square root 2 small r, so capital R squared equal to 2r squared, so this is actually just 1, so x squared plus y squared equal to 1. That's the director circle. Next question, equation of the director circle, oh okay, of the circle x squared plus y squared minus 2x plus 4y minus 4 equal to 0 is, so just write it in general forms like x minus 1 squared plus y plus 2 squared equal to 4 plus 1 plus 4, which is 9, which is also r squared, so r equal to 3, capital R equal to 3 square root 2, r squared equal to 9 times 2, right, which is 18, so just replace this by 18 and that's it, because they're concentric, right? So this part stays the same. Cool. So x squared minus 2x plus 1 plus y squared plus 4x plus 4 equal to 18. So x squared minus 2x plus y squared plus 4x, 1 plus 4 is 5, so 5 minus 18 is minus 13 equal to 0. That should be doing it. Is x squared plus y squared plus 2x minus plus 4y, this is y, minus 13 equals to 0. Cool. Let's go to the next question. The number of points with integral coordinates that are interior to the circle x squared plus y squared equal to 16 is, I think I've done this kind of question once, but it was with a straight line. Okay, so let's just say that if we have a point with integral coordinates a comma b, so here a and b are integers, and it is interior to this circle, which is actually centered at 0 comma 0, so that distance is like a squared plus b squared, square root of that. So this should be less than 16, right? This should be less than x squared plus y squared, which is 16, correct? So That's nice. And these two are yeah, these two are integers. So if we were to find positive solutions for these integers, let's try them out. So you can have 0, right? You can have 0, and then for b, okay, so a equal to 0, and for b you could have 0, 1, 2, 3, not 4 because that would be 16, which is not less than 16. You can have a equal to 1, that's gonna give me b equal to 0, 1, 2, 3. Yeah, that looks correct, right? 9 plus 1 is 10, less than 16. A equal to 2, b equal to 0, 1, 2, 3, right? 9 plus 4, 13. A equal to 3, b equal to 0, 1, 2. Okay, so stop there because 9 plus 9 is 18. That's not gonna work. Okay, a equal to what is it? A equal to 4 and b equal to 0, 1, so 16. Oh, wait a second, that's not gonna work. A equal to 4 is already 16, so that's where we stop. So how many solutions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11 solutions, actually 11 positive integer solutions for a comma b, right? So 11 times 4, because if you got a comma b, I should say magnitude a comma magnitude comma b, then you can also have minus magnitude of a comma magnitude of b, and then minus and minus, and this guy, right? So there are 4 solutions for each solution of the 11 solutions, whatever. So this is actually 44 solutions, so 44 points with integer coordinates. Did we also cover that 0, 0? Yes, we covered that. Cool. Let's go to the next. Wait, oh no, oh yes, there's a problem with this thing. There are not actually 44 solutions. No, there are not 44 solutions because we overcounted them. The coordinates which are on the axis, we overcounted them, sorry, so it's not 44. So now we need to see how many times we overcounted them. This is getting tedious, very tedious. Okay, so which of them are on the x-axis, right? So a squared plus b squared is less than 16. Which of them are on the x-axis? So if a is 0, then b can be 1, right? 2, 3, and not 4, so we did not count that at least. So we counted these twice, so now we need to subtract them, right? So how many of them? It's like 1, 2, 3, and that times 2 because plus minus plus minus plus minus, so 6, so minus 6. And then similarly for b equal to 0 you got 1, 2, 3, and plus minus plus minus plus minus, so minus 6. And for the special case 0, 0, we actually counted it 4 times. Yeah, that's bad, so subtract it 3 times, right? And that should be doing it correct. So minus 6 is minus 12, that minus 3 is minus 15, so this minus 15 is going to be 29, right? This was really tedious. I didn't expect this question to be that hard. Okay, the equation of a tangent to the circle x squared plus y squared equal to a squared, which is parallel to the line square root 3x plus y plus 3 equal to 0 is. So this is parallel to this line, so like square root 3x plus y plus c equal to 0, that could be the equation of this tangent, and it is tangent to this circle. So suppose you got a tangent to some circle which is square root 3x plus y plus c equal to 0, and this circle is centered at 0, 0, and the radius is a. What we can do is that we can find the perpendicular distance from this point to this line. So that's gonna be just magnitude of c upon square root of root 3 squared is 3 plus 1 squared is 1, so it's 4, so it's magnitude of c upon 2, right? and this perpendicular distance, that should be the radius. So this is a, right? Yes, that's gonna give me mod c equal to 2a, so c equal to plus or minus 2a. That's doable, right? We are not specified whether a is a positive number or not, but let's just deal with this then, right? So c is plus minus 2 mod a, so this is gonna be square root 3x plus y plus minus 2 mod a equal to 0. Cool. Let's go to the next question. For what value of lambda the line 3x plus 4y plus lambda is tangent to the circle x square plus y squared equal to 10x? So it's actually shifted. So x minus 5 squared plus y squared equal to 25. Yes, this is the radius actually. So this is centered at 5 comma 0. So it's gonna give me like r equal to 5. Centered at 5 comma 0. The line is 3x plus 4y plus lambda equal to 0. So the perpendicular distance, that is 15 plus lambda upon square root of 3 square plus 4 square, that's 5, and this should be equal to 5, right? So lambda equals to 25 minus 15, which is 10. So lambda is 10. Cool. Did I miss something? Yes, I missed something. It's a mod over there, so this is just one value, right? It could also be 15 plus lambda equal to negative 25. That's also gonna give me one value, so that's gonna give me lambda equal to minus 40. The range of values of a for which the point a comma 4 is outside the circle x squared plus y squared plus 10x. Did we not? Okay, x squared plus y squared plus 10x equal to 0 and x squared plus y squared minus 12x plus 20 equal to 0 is okay. So outside of both of the circles, I guess, right? So yeah, let's just do it. Cannot we do it using that power of point concept? We know that if a point is inside a circle, its power is negative, right? It's negative. And if it's outside the circle, its power is positive. And if it's on the circle, its power is 0. And because it's on the circle and power is 0, that's how we get the equation of circle, really, using power of point concept, right? So we can use that, can't we? So we're just gonna put the coordinates of this point into these equations, and let's just see about the power of point. So a squared plus 16 plus 10a, right? It's outside of these circles, so it's positive. This power is positive. And a squared plus 16 minus 12a plus 20 is also positive. Oh, so these are two quadratic inequalities. I hate these. Okay, let's solve. So a squared plus, can't we just factorize 16 into something? 4 and 4 won't work. 8 and 2 will work. A plus 2 into a plus 8 is positive. That's gonna give me a is less than 2 or a is bigger than 8. And over here this is 36, right? This thing is 36. 36 is 6 into 6, so a minus 6 squared is positive. Yes, so that's just telling me a is not equal to 6. That's it. So a belongs to negative infinity to 2 union 8 to infinity, right? 6 was never included in this set. So cool. So it's outside of this circle and at the same time that circle too. Nice. Yeah, unless I missed something. So this is going to be in negative infinity comma 2 union 8 comma infinity. I just hope this is correct. Next question. The equations. Oh yeah, the equations to the tangent to the circle x squared plus y squared minus 6x plus 4y equal to 12, which are parallel to the straight line 4x plus 3y plus 5 equal to 0 are. So these are tangent to this circle and parallel to the straight line. Okay, So 4x plus 3y plus c equal to 0, and this circle is just x minus 3 squared plus y plus 2 squared equal to this. So 12 plus 9 plus 4, 9 plus 4 is 13 plus 12 is 25. So I is equal to r squared, so r equals to 5. Center is 3 comma minus 2, so put that in there. So it's going to be 12 minus 6 plus c, the magnitude of that, upon the square root of 4. So the difference is 5 equal to 5, so this has to be 25. Cool. So what's this? 12 minus 6 is just 6, so 6 plus c equal to 25 or minus 25. So c is 25 minus 6 is 19, or c is minus 31, right? Yes, that's correct. So it's gonna be 4x plus 3y plus 19 equal to 0, or 4x plus 3y minus 31 equal to 0. Cool. Let's go to the next question. How long is it gonna take me? Next question is the equation of any tangent to the circle x squared plus y squared minus 2x plus 4y minus 4 is. Any tangent, okay, so a general equation maybe, right? So let's just use parameterization in that case. So this is just x minus 1 squared plus y plus 2 squared equal to, so 4 plus 1 plus 4, that's 9, equal to r squared, so r equal to 3. So the parameterization is going to be 1 plus 3 cosine and minus 2 plus 3 sine, right? This is a parameterization of any point on the circle, and its center is 1 comma minus 2. Okay, so this is how it's gonna look. And then you got this tangent with, let's just say, slope m, or maybe not. Okay, let's just say it has slope m. So actually no, wait a second, let's not do that. So what's this slope? This slope is yeah, it's tan theta, right? So it's s by c. Let's see, you got some point x comma y on this, then this slope is y plus 2 upon x minus 1. So this times that slope s upon c, that should be negative 1, right? So it's going to be like sy plus, yeah, I'm missing something once again. Oh yeah, I'm missing something. This is not, oh god, this is not 1 comma minus 2. This point is the center, it's 1 comma minus 2, and this point is this thing, so it's not really y plus 2, it's actually y plus 2 minus 3 sine upon x minus 1 minus 3 cosine, right? So that's gonna be s times y plus 2s, okay, minus 3 sine squared equal to minus cosine into x, minus 1 into minus 1 is positive, so plus cosine plus 3 cosine squared, so sine theta into y plus 2 plus cosine theta into x plus 2, sorry, x plus 1, oh god, x plus 1, x minus 1, sorry, once again, x minus 1 equal to 3 sine squared plus 3 cosine squared, just 3. So yeah, that's it, that's the equation. Cool, right? Let's move on to the next question. If a circle whose center is minus 1 comma 1 touches the straight line x plus, shit, what happened? Okay, if a circle whose center is minus 1 comma 1 touches the straight line x plus 2y plus 12 equals to 0, then the coordinates of the point of contact are, oh come on, really? So that's the point of contact, it's got x comma y as its coordinates. So y minus 1 upon x plus 1 into this slope. This slope is just negative 1 upon 2 equal to negative 1, right? So negative 1 gets cancelled, so y minus 1 equal to 2x plus 2. So y equal to 2x plus 3. Nice. So let's put this into that equation. Alright, so x plus 4y plus 6 plus 12 equal to 0. So 5y plus 18. Oh, that's weird. 2y, right? So yeah. Did I do something wrong? X plus 2y. Slope is negative 1 by 2. That cancels. That's correct. 2x plus 2. This must be correct. This must be correct, right? So 5y is actually negative 18. So y equal to negative 18 upon 5. Oh, that's nice. We got the y coordinate. Let's put that in this. So x, okay, so put that in this, minus 36 upon 5 plus 12 equal to 0. So x equal to 36 upon 5 minus 60 upon 5. So this is minus 24 upon 5. I really think we have done something bad, but whatever. Minus 24 upon 5 minus 18 upon 5. Yeah, these are the points of this is the point of the contact. Minus 24 upon 5 minus 18 upon 5. Next question. Okay, let's just keep going. How many of these are there? From a point, oh, so there are 20 of these. Bad. From a point on the circle x squared plus y squared equal to a squared, two tangents are drawn to the circle x squared plus y squared equal to a squared sine squared alpha. So these are two concentric circles. Okay, the angle between them is just geometry basically. This is one circle with radius a, and this is another circle with radius a sine alpha. So I should draw this first. This is a circle with radius a sine alpha, as for short, and this is a circle with radius a. Okay, right, so this complete thing is a. What do we know? We want to find the angle between the tangents from this point to the smaller circle. Okay, really bad drawing. So this is going to be a sine alpha, and this complete thing is a. So that means this angle is alpha. This angle is alpha. So yes, the angle between them is 2 alpha. That's easy. If the circle x squared plus y squared equal to 4 bisects the circumference of the circle, so it bisects the circumference. That means it's wherever it intersects, those 2 points are actually the ends of the diameter. Bisects the circumference of the circle x squared plus y squared minus 2x plus 6y plus a equal to 0. Then a equals, cool, I guess we can do this. So it's gonna bisect this circle. Hey, I think I can do this. So I remember something from the radial axis lecture. So if I somehow manage to get rid of these terms, let's just subtract these first of all. So minus 2x plus 6y plus a. This is minus 4, so subtract, you get plus 4 equal to 0, right? So this line is actually the radial axis. So that's gonna be, just leave it like that. Okay, so this radial axis is like also the diameter of this circle. Okay, weird. So this is also the diameter of this circle. Okay, how can I use that to find anything, I should say? How can I do anything with that? This is the diameter of the circle. Oh, maybe I can actually do this. Right, so what's the center of this circle? It's actually 1 comma minus 3. What's the radius? So radius squared is minus a plus 1 plus 3 squared is 9, so plus 10, right? So 10 minus a is radius squared, so radius is just square root of 10 minus a. Cool. All right, so the distance from this point to this line, the diameter, that should be 0, right? So if I put this in there, okay, why do you even need this? If this distance is already 0, why do we even need this? Let's put this in there. So minus 2, and this is got minus 18 plus a plus 4 equal to 0. So a, this is minus 20, minus 20 plus 4 is minus 16 equal to 0. A equal to 16. That's it. That's how we do it. Okay, so yeah, a equals 16. Just one value, nothing like a quadratic equation. If this were not a diameter, or if this were something like uh, I don't know, something where they had given something like the angle intercepted, or maybe the distance from the line or something like that, in that case it would have been very very different, right? Okay, but thankfully it was a diameter, so that makes it much easier. Life is easy. Next question. Equation of the circle passing through the origin and through the points of intersection of two circles, x squared plus y squared minus 10x plus 9 equals to 0, and x squared plus y squared equal to 4 is. So it's a circle passing through the origin and through the points of intersection of the two circles. Yes, so I remember something from family of circles too. I mean, the last question was dealt with family of circles. That is the radial axis. Whatever. So what's the radial axis of these two circles now? So subtract, I'm gonna get minus 10x plus 9 and minus 4 plus, it's plus 4 equal to 0. So 10x equal to 13. Yeah, cool. So x equal to 13 by 10. That's the line which we are interested in. So this is the radial axis, and you have a circle, okay, which is passing through the origin. I guess what, even that circle is passing through the origin. Wait a second, we already got a circle which is passing through the origin and is obviously passing through the point of intersection of these two circles, because yeah, it's one of those circles already. So how can we find another? This does not make sense. Yes, it's got to be this circle only. Yeah, like the diagram for this question is gonna look something like this. So you got this circle which is passing through the origin, you got some other circle, right? I don't know, it's intersecting this circle at 2 points, and then the question is asking find a circle which is passing through these 2 points. Wait a second, and passing, oh sorry, this circle has center at origin, it's not passing through the origin. And am I an idiot? Okay, so now what? Now let's find the general equation of the circles passing through those 2 points. So x squared plus y squared minus 4, that's one of the circles, plus lambda, okay, actually write it like this, 10x minus 13 equal to 0, plus lambda times 10x minus 13, this is equal to 0, right? Those two points satisfy this equation, and this is obviously a circle, so that's also nice. Okay, and we are told that this is passing through the origin, so just put 0 comma 0 over there. So this is minus 4 plus lambda into 0 minus 13. Yeah, so minus 13 minus 4 equal to 0. Sorry, minus 13 lambda. So lambda equal to 4 upon, actually minus 4 upon 13. Yeah, that's it. That's nice. So lambda is 4 upon 13, so we're gonna put that over here. Oops, what happened? So x squared plus y squared minus 4 minus 40 upon 13 x, okay, plus 4 equal to 0. This cancels. So yeah, 13x squared plus 13y squared minus 40x equal to 0. That's the equation. 13x squared plus 13y squared minus 40x equal to 0. I doubt this is correct because it's not a nice answer. Next question. Length of the common, wait a second. Oh, this is for that question. 13x squared plus 13y squared minus 40x equals to 0. This is the next question. Equation of the circle passing through the origin and through the points of intersection of the x. Oh, and the line. Oh, all right. So we are already given this line, and we are told it's passing through that. So yeah, it's pretty easy. X squared plus y squared minus 2x plus 4y minus 20, right? Plus lambda times x plus y minus 1 equal to 0. That's the family of circles, right, which are passing through those 2 points. Are these two gonna intersect? Well, yes, I think they are. What's the, let it be, if they gave it in question, it must be that these are intersecting. Okay, and it is also passing through the origin, so 0 comma 0 is fine. This, so this gets cancelled, right? It's just minus 20 over there, cancelled, so it's minus lambda equal to 0, so lambda equal to minus 20, right? So put minus 20 over there, so it's going to be x squared plus y squared minus 2x plus 4y minus 20 lambda, sorry, minus 20x minus 20y plus 20, right, equal to 0. This cancels, so x squared plus y squared minus 2x minus 20x minus 22x and minus 16y equal to 0. Right, let's write that down. X squared plus y squared minus 22x minus 16y equal to 0. Okay, next question. Length of the common chord of the two circles 2x squared plus 2y squared. Oh god. Minus 5y plus 2 and x squared plus y squared minus 4x. Is anything else written? Yes. 4x plus 8y minus 18 equals to 0. Now what? We can find the equation of the common chord, but then finding the length of the common chord, I guess it's not gonna do if we just find the equation of the common chord. We will also have to find the intersection points in that case, which is not fun. Let's do it like this. Find the radius of the first circle. Actually, first of all, write it in a proper format. So x squared plus y squared plus 7 upon 2x minus 5 upon 2y plus 1 equal to 0. So x plus 7 upon 4 squared plus y minus 5 upon 4 squared equal to, okay, so 7 upon 4 squared, that is 49 upon 16 plus 25 upon 16 minus 1, which is, this is taking forever, so 674 upon 16, right? Yeah, minus 1, 74, 24, 24, no, it's not gonna work. Okay, this is messed up. Alright, we'll just deal with this. So 74 minus 16 is 6, and then you got 58 upon 16. This is a multiple of 4. Yes, no, it's not. So 2, it's going to be 2, and then 18 is 9, so 29 upon 8 is r squared. Okay, so I should say r1 squared. So r1 squared equals to 29 upon 8. Okay, the center 1, it is minus 7 comma 4 and 5 comma 4. What is r2 now? This is not good. This is taking forever. X squared plus y squared minus, oh, okay, square plus y squared minus 4x plus 8y minus 18 equal to 0. The center 2 is 2 comma minus 4, right? Radius 2 squared is 18 plus 2 squared, which is 4, plus 14, 4 squared is just 16. So this is 20, so this is 38. So r2 squared is 38. Right. First of all, let us find c1 c2. So c1 c2 squared, that is, okay, so this is gonna be minus 17, okay, 8 plus 7 is 15 upon 4 squared plus 16 plus 15 is like 21 upon 4 squared. Oh god, yeah, which is, let us take that 3 by 4 common, so 3 by 4 squared common. This is 5 squared 25 plus 7 squared 49, 3 squared, so it's 9 upon 16 into, this is 674, right? Okay, so this is 8, this is 35 into is 37, this just comes out to be 9, what is this, 9 times 3 is 27, and then 63, so 333 upon 8. It could be possible that this is a Pythagorean triplet maybe. So this can be written as multiply by 8, so 24 and 64. This is 304. Okay, now, oh yes, it is actually a Pythagorean triplet. I mean, seriously, it's already tough, and then they want you to apply the cosine law. No way, that's not gonna happen. So we know this is a Pythagorean triplet. Okay, let's now draw the diagram. So this is like the radius of the first circle, right? It's r1 squared is 29 upon 8. I don't know. This is another circle, right? And this is the common chord, right, which is perpendicular to this thing, and this is like that. What do we do now? So we need to find the length of this thing, right? We'll just use area in that case. So this times that, actually this squared times that squared should be this squared times that squared, right? Because of area, just this area is constant. So 29 upon 8 into 38, that has to be 333 upon 8 into the length, actually half the length of this common chord is called this L by 2, yeah, squared. Cool, so let's just do this. 8 gets cancelled, okay, anything common, 29, 38, 333, 111 is a multiple of 3, so it's 3 into 3, 9, 21, 97. No, it's really weird. So it's 29 into 38 upon 333 into 4, and then the square root of that. That is our L. I'm never doing this again, right? So that's L. Yeah, I bet this is a perfect square at all, because 29, yeah, it's not, 333 doesn't look like it's a multiple of 29. I mean, 79 is not a multiple of 29, right? Yeah, that should be it. So that's it. It's this weird answer. So it's like 2 square root of 29 into 38 upon 333, which I'm not gonna calculate because who would really? Let's cut this and let's erase all this stuff. Wait, they did not give an answer for 20. How can that be? So 20, this has no answer. Why? Could it be that these are actually not intersecting? No, that cannot be because these are intersecting, right? They form a Pythagorean triplet and stuff. That's not possible. Why did they not give an answer? That's not correct. I don't know. Okay, let's check now. First question I solved and got x plus y square root 3 minus 8 equal to 0. Yes, that's the same thing. X plus 3y minus 5 equal to 0. Yes, correct. 2x plus 9y minus 30 equal to 0. Oh, that's opposite of what they got. That's not correct. I got something else. Find the equation of normal. Oh, sorry. Find the... What? Oh no, I did a completely different question in that case. Find the equation of the normal to the circle at the point minus 3,4. Okay. So over here the slope is 9 by 2. For the normal, this slope should be minus 2 by 9. So minus 2 by 9 is y minus y plus 3 upon x minus 4. So minus 2x plus 8 equal to 9y plus 27, right? So 2x plus 9y plus 27 minus 8 is, what's that? It's 19 equal to 0, right? 19 or what? Did I do it correct? It's at... Oh, no, I did not do it correct. Is my brain stopped? Has my brain stopped working? What am I doing? This is completely incorrect. So it's minus 2x minus 6 equal to 9y minus 36, right? So 2x plus 9y equal to 36, minus 6, which is 30. Yeah, that's what they got to. So cool. Question number 4th. The angle between yeah, we did it, right? We did it. And we got things in terms of sine inverse, which, I mean, it is really not that good. Yeah. Was it sine inverse or something else? Was it tan inverse maybe? I don't know. So 4th question. Yeah, it was definitely not that. Yes, we got something in terms of sine inverse. If we had solved a little more, so yeah, actually the diagram was something like this, right? This thing is s1, this thing is a, this thing is square root of a squared plus s1. Yeah, actually this is square root of s1. Okay, so yes, in terms of tan inverse, this tan theta is a upon square root of s1, so it's 2 tan inverse of a upon square root of s1. In terms of sine inverse, it is 2 sine inverse of a upon square root of a squared plus s1. Cool, that's nice. So yeah, that is correct. 5th, 3 by 4. Yes, that's what we got. 6th, yes, correct. 7th, minus 2x plus 4y minus 13. Yes, correct. 8th, where is it? 45. I don't know. Once again, it got messed up maybe. The interior to the circle is... Actually, I will do that once again, but on a different video. So that time is gonna say no, it's not correct. So move on. 9th, square root 3x plus y plus minus 2a. So yes, a is positive over there. I mean, even if it's not positive, it still doesn't make a big difference. So yes, it's correct. 10th, extension to x squared plus y squared equal to 10y. So 10 and minus 40, yes, that's correct. 11th, union 6 to infinity. Okay, is outside the circle. Well, that doesn't make sense. So the first equation gave us that, yeah. And then the second equation, what was the second equation? Something is missing. Oh yeah, it's the same thing. Sorry. what was I even thinking? So it is actually the same thing. It's just negative infinity to negative 8 union minus 2 to 6 except 6, right? So that's why they have did this thing to not include 6 and wrote it like that. So it's actually correct. 12th, yeah, that's correct, and that's also correct. 13th, the equation of any tangent to the, so yeah, they did we did that and we got it in terms of sine theta and cosine theta, so that parameterization, and they did it in terms of the slope. I guess it's not that hard to switch because really slope is just tan theta, so it should be doable. Yeah, cool. So I guess I'm gonna give it a correct. 14th, 24 upon, maybe I just switched it. Is it 21 or 24? It's minus 18,5. Maybe I solved for x and then got something different. I don't know. Wait, I remember solving for y and then I got, oh no, yes, now I got it. It should have been x over there and I actually solved for y, which is wrong. So actually I should have got x equal to minus 18 upon 5, and substituting that into this equation, that's gonna give me minus 18 upon 5 plus 2y plus 12 equal to 0. So minus 9 upon 5 plus y plus 6 equal to 0. So y equal to 9 upon 5 minus 6, which is, so 9 minus 30 is minus 21 upon 5, which is exactly what they got. So it's just a silly mistake, and yeah, I was not able to do it correctly. 15th, from a point to the circle x squared plus y squared equal to a squared, two tangents are drawn to the circle. Why am I reading this? Angle, right? So 2 alpha, correct. 17th, correct. 18th, yes, that's correct. 19th, x squared plus y squared, yes, that's also correct. And 20 didn't give an answer, whatever. So I will stop now because it's been a big time. Okay, see you in the next video. Bye.